Okay. It is very similar to multiplying, as I have said here. So just to remind you, excuse me, multiplying, quick reminder, 2x times 3y equals 6xy. To root 3 times 3 root 5 equals 6 root 15, right? To cube root 3 times 2 square root 5 is 6 cube root 3 square root 5. That's all multiplying, yeah? Yes? Oh, yeah, of course I mean 4. Right? That's multiplying. Everyone's cool? And all that comes from the XY rules, right? Okay, dividing is very similar. If I had 6x over 2y, what would the answer be? Karina? 3x over y. Why? Because 6 divided by 2 is 3, and x and y can't do anything. Why? Because they're not like terms. Okay? What if I had 10x squared over 5x? What would that simplify to? Just 2x, because x squared divided by x is 1x. Right? Everyone remembers this from the 9th grade, yeah? Okay. Dividing radicals is the same thing. Numbers go with coefficients go with coefficients. Variables go with variables. So what do you think happens here? 6 root 12 over 2 root 6. What do you think will happen there? Karina? You could simplify the 12 to what? That's going to end up being 12 root 3, right? Over 2 root 6. You could do that. That's one option. Knowing what you know from up here, what is another option you could have down here? Coefficients with coefficients to get what? 3. And roots with roots. Now, are they the same index? When they were the same index and it was multiply, what did we do? We multiplied the radicands, yes? Are these the same index? So what do you think we should do? Divide. What do we get? Root 2. Is everybody cool with that? Okay? Just like with fractions, if it divides, it divides. Everyone okay? All right. So what then do you think this is? Root 6. Everybody cool? Now, Karina said, but Mr. Myers, why wouldn't we simplify there? Well, let's do that. What does 9 simplify to? What does 18 simplify to? 9 times 2, yes? So this is 3 root 2 over root 3, correct? Happy with that? Okay. Everybody all right? So, what else is this? If this is square root and this is square root, then is this whole thing the square root? Right? And what is 18 divided by 3? So this is the square root of 6. Does everybody see why this line works? Does everybody understand why that works? Both things there, yes? Okay, now I want to show you something. Square root of 6. 2.494, blah, blah, blah. Irrational number, yes? 2.45. We happy with that? Okay. Watch here. 3 square root 2 equals that, divided by the square root of 3. Same thing. Everybody understand? Now, I need for you to understand everything in yellow, and I need you to remember what that looks like in a couple of moments. Okay? Everybody with me? Everybody understands how this worked, yeah? And then you all understand what Karina did here, right? Right? She just simplified the 18, yeah? Okay. We're going to come back to this in blue in a moment. But right now, we're going to stay, I need you to be cool with the yellow, yeah? All right. Now, did you guys have the typo here that is missing that X? Is it missing from your book? What a pain in the rump. Please write it in. All right, now you guys are smart kids. What's going to happen here? Divide, what is it? 5, excellent. Root, what's going to happen here? What did we do with 18 and 3? Divided, so what do you think we do with 15 and 3? Divide, excellent. What did we do with x squared and x here? We subtracted the exponents just like we learned in grade 9. So what do we do here? To get 3 minus 1 is x squared. What about this one? Y. Everybody cool? Now, can I leave it like that? Why not? Something about that can be fixed up. What, Karina? There's a square x's there, yes? That's 2 x's, right? So how many x's come out here? 1. 5x root 5y. Is everybody cool with the easy stuff? Now, what have you noticed about every number that we have had in these two examples? They're easily divisible, yes? 4 over 2, 8 over 4, right? We can easily simplify because they divide perfectly, right? Now, you guys aren't stupid. You're aware that there are fractions that look like this. Over 24, right? They don't divide easily, do they? But we know how to simplify that, yes? We would divide both by 8 and get 8 over 3. Cool? Priyanka. Yeah. X3. No. Okay. What's the root of 9? 3, because it's 3 times 3, right? And I take out a group to get 1, 3. Cool? Okay. Everybody good with the easy stuff? Yeah? Dylan?
I'm sorry. So on the top it's x cubed, and how do you only end up with x squared?
Because this is x cubed over x, yes?
Yeah. So
which is x over x, yes? They cancel, leaving me with x squared. Okay? All right, everybody still good? These are good questions. I like them. Now, you should have something here that says nature of radicals here. Yes? Okay. The nature of radicals is, what I'm trying to say there is you have, there are some things that we aren't allowed to do with radicals. Okay? One of the things that we are not allowed to do with radicals is divide by them. All right? So the first thing we have to know about radicals is a radical in the denominator is not allowed. Okay? We're not allowed to have that. Does anybody want to guess why? Does anyone want to guess why I don't want a radical in the denominator? Karina. I'm sorry? Yeah, not whole number, that's the wrong word, but you're on the right track. What are most of these? Irrational. Which means how long does that number go on? Forever. And ever, and ever, and ever. Could you ever stop dividing it if you left it as a decimal? No, you could never stop dividing it, could you? So this is no good. Okay? Radicals in the denominator is not allowed if it's irrational. Okay? So that is not okay. How would we fix that? What are we allowed to do to every fraction that doesn't actually change the fraction? What can I do to this? Oh, I got to get that from you guys too. What can I do to this to keep that value but not change? To change how it looks but not change its value? I'm not making it bigger. I'm multiplying, yes? If I multiply this by 3 and I multiply this by 3, I get 6 ninths, yes? Not 6 19ths. 6 ninths. Is that the same fraction? Does it look the same? No. So now come back to what we're talking about. What? Yes. Right, so I can't multiply it by x, I need to multiply it by root x. This is not allowed if it's irrational. So what must I do? If I multiply this by root x over root x, why did I have to multiply by both? Pardon me? It's going to give me a cancellation, but why did I have to multiply the numerator and the denominator by the same thing? The fraction stays the same because this equals what? 1. And does multiplying by 1 change anything? No. So what happens here? What is root of x times the root of x? X. And what is 1 times root x? Root x. Now, I can stop my division, can't I? Is everybody with me? This is called rationalizing the denominator. And we have to do it because we're not allowed to divide by a radical if it's irrational. Everybody cool? All right. That's one. The second problem is this. What if I have root x minus 6? Have a look at that. What about that is not allowed? I can't have that radical in the denominator, can I? We know what to do. We got to multiply by 1, yes? And we know that 1 has to have a root, yeah? Everybody cool with that? Okay. So if I multiply that, what's going to happen when I multiply root x times root x? I'm going to get x, yes? What happens here? I'm going to keep a radical, aren't I? Right? That's no good. So I'm in trouble, yeah? So what I would get is this, minus 6 root x, wouldn't it? Right? Now, if I want to get rid of that root x, what do I got to do? I have to multiply by root x, wouldn't I? That would put a root x back in here, wouldn't it? Right? So I'm in trouble here. But I'm not really in trouble here because I can multiply by something called the conjugate. I need to take care of this negative 6, yes? What would take care of a negative 6? Positive 6. Now, what happens? What's root x times root x? X. Plus 6 root x. Then what's this one? What's that? 6 root x. And what's this guy? Negative 6 root x. What's going to happen? They're going to disappear, aren't they? So what I'm going to get is x plus 6 root x minus 6 root x. And then what's the last one? 6 times minus 6 is negative 36, right? What happens in the middle here? They disappear, leaving me with x minus 36. Is that cool? Any radicals under there? No. This is what we call the conjugate. You've seen the word in French, but it doesn't mean the same thing. Okay? The conjugate is the same expression with opposite operations. Now, as you can see, we're still multiplying by 1, but we're making that radical disappear, right? So in this question, what would I need to do to make those radicals disappear? What is the conjugate? Same expression with opposite operations. So what's the first term? What's the first term? I'll highlight again. Same expression with opposite operations. What's the first term of the conjugate going to be here? Pardon? No, the operation in the middle is going to be positive. What is the first term of the conjugate going to be? The conjugate is the same expression. Same expression, he said a third time. Same expression, he said a fourth time. Root 17 plus, because of opposite operation, 3 root 14. So that is the conjugate. What's this one going to be? Root 34 minus 4 root 2. What's this guy's conjugate going to be? Root 5. Same expression. Are there any operations? So there's no operations to change. Everybody good? What's the conjugate's job? Conjugate's job is to eliminate radicals, which we have a proper term for, is called rationalize the denominator. Do we have to rationalize a numerator? No. We only rationalize denominators. Everybody cool? All right. So you guys should be on your next page now. Look at A and tell me if you can do anything with it right now. Coefficients with coefficients, radicals with radicals. Is there any division you can do? No, because 2 doesn't divide by 3, 6 doesn't divide by 7. So we're done for the easy stuff, yeah? But when we look at that, we see what? I'm not allowed this, am I? Is that allowed? So what do I got to do? I got to rationalize the denominator, which means I got to multiply by something that won't change the value. I could multiply by 3 root 7. That will change the value though, won't it? What's missing here? I need another 3 root 7 because I have to multiply by 1. Right? So what do I get now? What happens with 2 and 3? 6. And what happens with 6 and 7? 42. Over, what happens with 3 and 3? 9. And what happens with 7 and 7? It's 49, but it's root 49, so it's 7. So I get 6 root 42 over 63. Is everyone okay with that? Do I have a radical in the denominator? No, so that's okay. Can I simplify anywhere? 42 is 2 times 3 times 7. Any pairs? Nope. So am I done? Yeah. Almost. What can I do with numbers and numbers? Do they share a factor? What number goes into 6 and 63? Pardon? If I gave you this as a fraction, what would you do with it? Simplify it. To what? You would divide them both by 3 to get 2 over 21. But there still has to be a root 42 in there. Is everybody good? Tavleen.
Could you do that without, like, at the very first step, could you do that without times the multiple directory? You just times it like 5 and 7?
Yes, I'm getting to that in a second. Tavleen just jumped to what I was about to ask. Do I need those 3s? No, because I'm only trying to get rid of the 7, yes? Here's the problem. If I did that right away, and I went 2 root 6, 3 root 7 times root 7 over root 7, then I get 2 root 42 over 3 times 7 is 21. I get the right answer, yes? And everybody sees that, right? Here's what the problem is with showing you that first. All of you then are looking for shortcuts. And if I give you something else, I'm going to highlight this in green because we're going to come back to why I didn't show you that first in a minute. There's a reason. But before we do that even, I want to go back to here. Remember this situation? We all agreed with what Karina did, yes? But now we know that's not okay, right? So what would we do here? What would we multiply by? Root 3 over root 3, correct? Okay, so that is 3 root 6 over what? 3. What do you do with the 3's? Cancel. And there's our root 6. Everybody cool? Okay? Now, can we put that out of our mind now? Karina was right. We would simplify, but she didn't know that roots weren't allowed in a denominator at that point. Now that you do know that roots aren't allowed in a denominator at that point, you can see that we would end up with the same answer. But because this divided perfectly, we're allowed to divide perfectly. Everybody cool? Okay, that's the first thing. We can let that out of our head now. Now, keep this in your head because we're going to come back and deal with this in a minute. Wah! Okay, now remember, you guys have seen that this green thing does work. So over here, what are we going to multiply by here to clean this up? What must we multiply by? We have to do root 6. Now, Tavleen and various other people in the room saw that that will work, won't it? So I'm going to get 7 root 30 over 14 times 6, yes? Everyone agree? Okay, so what are we doing there? What is this going to equal? 7 root 30 over what? 84, right? Right? Do 7 and 84 work together? Excuse me. What is it? Root 30 over 12. Everybody cool? Tavleen.
Also, another way, could you have solved it first? Like, could you have said 2 over?
Could I have simplified now?
Yeah.
Could I have made this 1 root 5 over 7 root 6?
Yeah. And then,
Yes, of course I could have. Everybody good? Okay, so you guys now look at this one and tell me what's weird, or what might you be able to do with this? You know you could multiply by 18, yes? But then you would get, I'm going to work over here because this isn't where I really work, right? Could I multiply by root 18 over root 18? Yes or no? Is that allowed? Yeah. What do I then do with 18 and 50? That's a big number, isn't it? So what should I do here? What's my usual first step in math? Starts with an S, ends with a Y, has implify in the middle of it. Simplify. Isn't this 6 root 25 times 2 over 5 root 9 times 2? Isn't it? What's the square root of 25? So what comes out? 5. What's 5 times 6? 30 root 2 over, what comes out? 3. What's already out? What do I do? 15. What did I leave under there? What can I do as soon as I see the same thing on the top and bottom of a fraction? Cancel them out. And 30 divided by 15 is 2. Does everybody see where I'm going with this? Could we have done it by actually rationalizing the denominator? Did we need to? No, because we simplified first. Could we get there doing the whole long way? Yeah. But if you can simplify it, why wouldn't you? So have a look at D and tell me if you would simplify first or if you would actually start rationalizing the denominator right away. You're going to simplify first. What is this guy? Tavleen. 6 root 15. Because that is 4 times 15, right? And out comes the 2. Over what's this guy? 6 root 3, right? 6 over 6 cancels. Root 15 over root 3, does that divide? To get what? Root 5. Do I need to rationalize anywhere? No, because the denominator here is 1, and that's okay. Could we have done it by going root 27 times root 27? Sure. And 60 times 27, we would have had to have like 1,800 and something, right? Who wants that? Simplify first. Everybody good? Okay, you guys try E. It looks different. Do you think anything changes? Okay, say to yourself, self, can I simplify? Can you? No. So then we move to our next step. What about that is not okay? The root on the bottom. So I know I got to multiply by root 3 over root 3, yes? And I know on the bottom that's going to get me 3, because root 3 times root 3 is 3. Now, up top I'm multiplying, but what's different about this now? There's 2 of them. But I know how to multiply polynomials, because I did grade 9, right? That root 3 goes there first. What do I get? 6 root 6 minus, then it goes there. What's that? Root 3 times root 3 is 3, correct? Now, can I do any canceling? Do 6 and 3 work? What's 6 divided by 3? 2 root 6. And what's 3 divided by 3? 1 minus 1. Is everybody okay? Is everybody okay? All right, now look at F. And now this is where I need you to keep that other green thing I did in your head, right? Right now, what do I need to multiply by to tidy this mess up? Root 2 will take care of my radicals, right? This is what Tavleen was talking about. If I just use root 2, will my radicals disappear? Yes. So we're okay to cheat here, right? We don't need to use the whole denominator. We only need to use the part that we don't like, right? So you guys go ahead and work that out. What am I going to get up top? because root 2 times root 2 is 2. There's already a 2 there. Is everybody cool with what I did? I didn't explain it because you all know how to multiply. Is everybody all right with everything I did there? The 2 distributed in. I then simplified the 24, found that I ended up with the same radicand, remembered that I can add and subtract when they have the same radicand, and then I simplified 2 over 4. Is everybody good? Okay, now remember, Tavleen has said, and I agree, that this is okay to run it by just root 2, because the only thing we care about getting rid of is root 2, right? Okay, now keep that in your head. Is everyone good with that? Okay, go on to G. Now look carefully at G. It's slightly different, isn't it? What do I got to get rid of? 2 radicals. So I must have to multiply by what? 2 radicals, right? But I must need to multiply by root 15. I must need to multiply by root 10. But if I multiply by negative, what's going to happen? Are those middle terms going to drop out? So I have to multiply by what? The positive. In this case, I must use what we call the conjugate. Remember that. So you guys are smart kids. You know that the middle terms are going to drop out, right? So if I worked this all the way out, I would have root 15 times root 15, which is 15, yes? Plus root 250, or 150, minus root 150, minus 10, yes? What's going to happen to this plus 150 and minus 150? It's going to cancel out. Now, we've done this twice, haven't we? And both times the middle terms have canceled out, yes? In math class, if something happens twice, how often is it going to happen? Every single time. So our shortcut here is just 15 minus 10. Because we know that 15 is going to get there, 10 is going to get there, and we know the middle terms are going to drop out. Everybody cool with that? Okay. And then up top, what's root 7 times root 15? Root 105. Plus root 70. Correct? Everyone okay with that? Do either of those simplify? 2 times 5 times 7? Nope. 2 times 3 times 7? Nope. So the answer here is root 105 minus root 70 over 5. And it doesn't simplify. Is everybody cool? Okay. Now, H is where we have to come to something that makes us think. What do I need to get rid of on the bottom? I need to get rid of a root 3, and I need to get rid of what? A root 2. And if I want to get rid of it, the sign has to change, yes? Now, if we follow Tavleen's idea of only doing the radicals, will that work here? I would get 2 times 3, right? Because 2 root 3 times root 3 is 2 times 9, yeah? 2 times root 9, 2 times 3. Is everybody cool with that? Okay. Then I would get minus 2 root 6. And what's this? Plus 1 root 6. Does the middle term drop out? No. So, does that tell you why I showed you the first time using the coefficient and waiting for you to discover you didn't need to? Because here, what do we need? Here, I need that coefficient, don't I? Or it's not going to drop out. Does everybody see that? Okay. if your denominator is binomial or bigger, but for us it's never going to be bigger than a binomial. If your denominator is binomial, you must use the coefficients. Does everybody understand? Tavleen? No. Oh, there's add or subtract between terms. You don't remember that from the 9th grade, guys? You don't remember the term binomial? Really? Karina, you were in my grade 9 class. Do I have to go back to my notes from last year? I won't. You... Okay, well, we're doing a whole unit on polynomials. Remind me to put binomial and trinomial back in there. Everybody cool? So, because this is binomial, I have to keep the 2. Now, will it work? Let's check. What's this on the bottom? What's 2 times 2? 4. What's root 3 times root 3? 3. Now, minus 2 root 6 plus 2 root 6. Does everybody see that it drops out? And then, root 2 times root 2 is minus 2, yes? Everybody cool? So my denominator is 12 minus 2, which is 10. Everybody's okay? Now, up on top here, I got to FOIL this, yes? First one, what's 3 times 2? 6, and 2 times 3? 6 root 6, right? What's the second one? Minus 3 root 4, correct? Now, why did I write root 4? We know that root 2 times root 2 is 2, yes? But for instructional purposes, I'm actually writing it out. Okay? Next one. Root 3 times root 3 is plus 2 root 9. Because I'm actually writing it out. And last, root 3 times root 2 is minus root 6, correct? Now, do you see some stuff you can simplify there? I got 6 root 6's, and I'm taking away 1 root 6. How many root 6's is that? I got 6 of them, and I'm taking away 1 of them. 5 root 6. And what is root 4? That's 2, right? What's 3 times 2? 6. What's root 3? What's root 9? 3. What's 2 times 3? 6. So I got minus 6 plus 6. What happens to these middle terms? They drop out. So what's my answer? 5 root 6 over 10, yes? Is it done? Why not, Max? Because I can simplify 5/10 to 1/2 root 6 over 2. Does everybody get it? What did we learn today? Division, if it divides, is easy. If it doesn't divide, it's a pain. We got to get rid of the denominator by rationalizing. If it's a single root, we just multiply by the root. If it's bigger than a single root, we got to multiply by everything with one reminder. It's the conjugate. And what is the conjugate? I'm going to write it again. Same expression, different. No, I shouldn't have written different. Opposite operation. Is everyone okay? Now, you guys should have, if I'm not mistaken, a couple more examples now, yes? Or no? No, you guys go straight into radical equations. Cool. All right, but you should have a blank sheet there, yes? Mostly blank? Okay. I'm going to write one out here, and I want you to try it before you go out on your own. Everybody ready? It's going to look weird. Okay? 10 cube root. What are you doing, Mr. Myers? You know what? I'm not that mean. We'll just make it a square root. 5x over 2. Oh my good gravy. Does that look like anything we've done so far? No. But let's stop and think about it a minute. Talk with your neighbor if you need to. What can we do to make this look like what we know? Talk to your neighbor for a sec, because it's a bit tricky. Okay. Who has an idea? I don't want the answer yet. Who has an idea to make this look prettier in a way that we can deal with it? Anybody? Tavleen?
I have 2 ways, and I don't know which one's right.
I know you shouldn't know which one's right because I haven't shown you this yet.
Okay, so what I do is split it up. So I go 10 times root 5x over root 2.
Like that?
Yeah.
Is that okay, everyone? Tavleen, why did you move this 10 up here?
That's my 2 ways of doing it. And I put the 10 there.
10 can't go on both.
Okay,
Here's why. What is this guy as a fraction? 10 over 1. So 10 is a numerator, isn't it?
Okay, yeah.
So the 10 goes up there. Is everyone cool? All right, now, does this look like something we can do? What don't we like there? Radical in the denominator. Is it a single entity? So I don't need to worry about the conjugate, do I? I just need to multiply by what? Root 2. So, what's on top now? 10 times what's the coefficient with root 2? 1. What's 10 times 1? 10. And what's this? Five x times 2.
Would it be root 10x?
It would just be 10x, just like it is in regular math, right? Over what? What's on the bottom? 2. Would I leave it like that? No. What do I do to finish that off? 10 divided by 2 is? 5 root 10x. Can I simplify 10? It's 2 times 5. Any pairs? So are we done? Does everybody see why it works? Even with the letter in it, did anything change? So do we need to worry about letters? They don't need to scare us because nothing changes. Everybody good? Now, we're going to do 2 more examples and I'm going to shut up. What if it does have a cube root? What if it is cube root 16 over cube root 2. What don't we like about this? What's no good? Radical in the denominator. Now, when it's a square root, we just square it, right? Right? So all we would do is we would do whatever's on the bottom times itself, yes? And then it would disappear, wouldn't it? But if I do that, multiply by cube root 2 over cube root 2, cube root 2 over cube root 2 equals the cubed root of 4, doesn't it? Does 4 have a cube root? So does it get rid of the decimal or the radical? No. So you got to think about this. I need there to be how many 2's under there to do a cube root? 3 of them. I've got 1 of them. So how many do I need to have here? I need 2 of them, don't I? Now I get the cube root of what? 2, and then 2 more 2's. 2 cubed, yes? Now do I have a group of 3? So that would just be 2. Does everybody see that trick? It's tricky, right? Because you want to just do the same thing. Oh, it's radical. I just got to multiply by radical. I'm done. But this, if I don't have that squared, I get the cubed root of 2 times 2, don't I? 2 times 2. Is that a group of 3? So I can't do a cube root there, can I? Does everybody understand that? If I make this squared, this becomes the cubed root of 2 times 2, doesn't it? Is that okay? And there's my third 2. Does everybody get it? So what would I do if I had a fourth root of 2? What would I have to multiply that by to get rid of it? How many 2's do I need under there? 4. I've got 1, so I would have to multiply by 2 cubed. What if I had the fifth root of 2? What would I have to multiply it by?
2 and the exponent 4.
2 to the 4th. 2 and 4 more. Everybody see it? Okay. What if I had the x root of 2? Then what do I got to multiply it by to get rid of it? 2 to the x minus 1. Does everybody understand? Because there's one of them and there's the rest of them. Does everybody see that? Going once. Going twice. Going thrice. It's exponent laws from last year, yes? I need to get 5 under there. I have 1. There's the 4 more. Right? I need to get x under there. There's the x less 1. Everybody cool? So we come back up to here and we fix this up. So now I have the cube root of 2, which equals 2. Everybody good? Now let's go up top. Cubed root of 16 times the cubed root of 2 squared. What is 2 squared? 2 squared is 2? 4. So this is the cubed root of 16 times 4, yes? Because 16 times 2 squared. Everybody cool? What is 16 times 4? Cubed root of 64. Can I simplify that? What is the cubed root of 64? Four. 4 over 2, which simplifies to what? 2. Everybody cool? Everybody good? Okay. I said we were going to do 2 more and then I was shutting up. I didn't think it was going to take that long to sort this out. Sorry. 4 over 3 minus 2 root 2. What's not allowed there? Is the numerator okay? Yep. Is the denominator okay? No. What's not allowed in the denominator? No radicals. Is this a binomial? Does it have more than one thing in it? So I got to use everything, don't I? Now I got to do the conjugate. So it's 3 what? Plus 2 root 2. And 3 plus 2 root 2 up top. Now, I've done enough of these that I know that the middle terms are going to drop out here, aren't they? So all I got to do is 3 times 3, which is what? 9 minus root 2 times root 2 is 2. 2 times 2 is 4. So this is minus 4 root 4, which is 9 minus 8. Correct? Because 4 times 2 is 8. Everybody cool? Okay, and what's up top? What's 4 times 3? 12 plus 4 times 2 root 2? 8 root 2. So 12 plus 8 root 2. What's 9 minus 8? 1. So it's 12 plus 8 root 2 over 1. Would we ever write over 1? Nope. So we're done. Is everybody cool? So let's summarize. Rationalize the denominator. Step, if we need to. Because we don't need to think about it. If the denominator disappears, we're okay, right? Everyone's okay with that, right? Square root 16 over square root 4 is the square root of 4, right? So we're going to forget about that. We know that. That's old news. We can do that easily. So what do we take away from today? 1, rationalize. Rationalize the denominator. How do I do that? There's 2 ways. If it is square root x, we multiply by root x over root x. Yes? Even if it's got a coefficient. That's the one way to rationalize. Everybody good? If it's the other way, if it's over y root x plus a, then I got to multiply by what? Y root x minus a. And what do we call that fancy new term we just learned? The conjugate. That's everything you learned today. Is everybody cool with it? So now you should be able to finish page, what was the last page I gave you? The page I said to stop at 124? 118, right? So now you're going to finish 118.